In this lab, we will continue with the applying machine learning methods on the collected data set from uh, houses in California. So in step 1, we read the data from the file, and in step 2, we explored the data set to familiarize ourselves with the data set and become comfortable with it. So to do that, we plotted box plot for each of the variables in the data set using Plotly. And we plot a histogram for each of the variables to see the distributions. We visualized the relationship between the geospatial attributes, longitude and latitude, with the median house price using static plot and geospatial plot using Folium. We identified all the missing values in the data, filled them using an imputer from sklearn, then double-checked if we still have those missing values. In step 3, we performed feature engineering. We created 3 new variables: average rooms per household, average bedrooms per room, average population per household. We encoded the categorical variable ocean proximity using one-hot encoder. We splitted the data set into 70% training set and 30% test set using sklearn. We performed a standard scalar and a robust scalar on both the train and the test data set for features. Then in step 4, we developed regression model. We implemented 3 different regression models: linear regression, RandomForest regressor, and XGBRegressor model. We tried our best to find the best parameters for these models to make sure that they have their best accuracy. We used randomized search CV and grid search CV. We evaluated these models using root mean squared error and mean absolute error has the criteria. Now in this lab, we will plot a comparison between these models. So in this lab, we will plot a comparison between linear regression, random forest, and XGBoost models. Now I am going to create a data frame of 3 different regression models and plot to see which model gives the best results. Create data frame of all the results from the standard scalar data set. df results ss equal pd dot data frame of all results ss, columns equal model, best score, RMSE, MAE, time taken. So all results SS has 5 values for each of the model, and we will give the names. We will put them in the column, and we will give the names to the columns as model, best score, RMSE, MAE, and time taken. And printing the table, the data frame gives something like this. So we can see the best score, the highest score is from XGBRegressor. The lowest RMSE and mean absolute error is from the XGBRegressor model. And the time taken for XGBRegressor is the highest, but for linear regression is the lowest. Then we import seaborne as SNS. Let's do the plotting. Let me show you step by step the plotting steps, and then let me do that in one go. Plot time taken, RMSE versus model. Let fig, x1 equal plt dot subplots of figure size equal bracket 7, 5. 7 is for the height and 5 is for the width of the figure, and the figure looks like this. As you can see, the tick marks are marked. We have the left and the bottom tick marks, but the rest of the parts are missing. Next, we add the title to this fig. x1 dot set underscore title of standard scalar model comparison colon RMSE and time taken for execution. Font size equal 13. Printing the fig, it gives this. So we can see that the title is added to the figure. So let's do the next step. Add X label and the Y label. Color equal tab colon green x1 dot set underscore x label of model comma font size equal 13. So the X label is model and the font size is 13. And x1 dot set underscore y label is time taken comma font size equal 13, color equal color. So color is green. So let's see. So the y-axis, y label is time taken and the font size is 13 and the color is green. Let's add bar plot of time taken. Let x2 equal SNS dot bar plot of x equal model, y equal time taken, data equal df results ss, comma pellet equal summer. So this is from the data frame df results ss. So model is linear regression, random forest regressor in XGBRegressor, and we plot time taken as in the bar. So it gives this. We can see that XGBRegressor takes a lot of time. And the color of these bars is summer. In the next step, let's do x1 dot tick underscore parameters of x is equal y. Printing. So we can see that the tick marks will be plotted on the y-axis. Then x2 equal x1 dot twin x open and close bracket. What it will do is that it will make this x-axis, this model x-axis, available for the x2 graph as well. And we can see now that the tick marks are showing on the x2 axis, y-axis as well. Color equal tab colon grid red x2 dot set underscore y label of RMSE font size equal 13, color equal color, so the color equal red, and printing fig gives us this. So RMSE is labeled to x2 axis and the color is red. Let's do x2 equal SNS dot line plot x equal model, y equal RMSE, data equal df results ss, sort equal false, so we don't want to sort the RMSE, comma color equal color, so color is red. So we want to plot the line plot using red color that shows the RMSE on the y-axis and the model on the x-axis, and that will be on the x2 axis. Printing fig. So we can see that the data hasn't been printed on the fig graph. Its printing has separately, and we can see the RMSE value is lowest for XGBRegressor. Let's do x2 dot tick underscore parameters of x is equal y, color equal color. So that will be tick marks on the y-axis of x2. So we can see that the data hasn't been printed on the fig graph. So to have the data printed on the fig graph, we have to run that in one go in one cell. So running that in one go in one cell gives us something like this. So we can see that the highest time taken is from XGBRegressor model, but the lowest root mean square error is from XGBRegressor. And the linear regression takes the lowest time, but the root mean square error is the highest. Then we will create data frame of all the results from robust scalar dataset. Let df results rs equal pandas.dataframe of all results rs, comma, columns equal model, best score, RMSE, MAE, and time taken. Printing df results rs gives us the model, best score, RMSE, MAE, and the time taken. So in terms of the models, we can see that RMSE is highest for XGBRegressor. And in terms of time taken, we can see highest time taken is from RandomForest regressor. So let's plot time taken RMSE versus model. Let fig, x1 equal plt.subplots of fig size equals 7, 5. So height is 7, width is 5. x1 dot set underscore title of robust scalar model comparison colon RMSE and time taken for execution. Font size equal 13. So we get this. Set X label and Y label color equal tab colon green. X1 dot set underscore X label of model font size equal 13. X1 dot set underscore Y label of time taken font size equal 13. Color equal color, and printing fig gives this. Plot time taken RMSE versus model. Let x2 equal SNS dot bar plot of x equal model, y equal time taken, data equal df results rs, and palette equal summa. x1 dot tick underscore params x is equal y fig. So we can see that separate graph is created for x2. And the highest time taken is from RandomForest regressor. Then we create x-axis for x2, and we want to use the same x-axis as the x1. Let x2 equal x1 dot tween x open and close bracket, and printing fig gives this. So we can see the values printed on the x2 axis, and x2 axis is the same x-axis as the x1 axis. Set y label for x2 color equal tape colon red x2 dot set underscore y label of RMSE font size equal 13 color equal color, and printing fig gives us this. So RMSE is in red color. Then we create line plot for RMSE. X2 equal SNS dot line plot of x equal model, y equal RMSE, data equal DF results RS, sort equal false, color equal color. So we are not sorting the RMSE values, and x-axis is the model, y-axis show RMSE values, and x2 dot tick underscore prompts bracket x is equal y, color equal red. So we can see a separate graph has been created for x2, and the tick marks are in red, and the color of the graph is red, and the lowest RMSE is from random forest regressor model, and the highest RMSE is from XGB regressor. So the random forest regressor model performed the best in terms of root mean square error, lowest root mean square error. Printing fig, we can see that none of the graphs are the bar plot and the line plot is not printed on the fig graph. So in order to do that, we need to do it all in one go, in one cell. So now we can see that the two plots are printed on the figure that we created. And we can see that the highest time taken is from random forest regressor model, but the lowest root mean square error is from random forest regressor model. And the lowest time taken is from linear regression. And the highest root mean square error is from XGB. So in terms of root mean square error, random forest is doing the best, and in terms of the time taken, linear regression is the best.